Hey, this is Don from Padlock Technologies again with another video. This video is going to be based on another video that I made about is MPLS secure? Now, if you haven't seen that video, again, I'm gonna put a card somewhere up here to give you a little bit more detail about is MPLS secure? Long story short, it is not secure. It is traffic separation, but the traffic is still clear text. So what I'm going to show you is a technique called GETVPN. On the whiteboard, we're going to go through some theory first before I show you in the lab. This is going to be a theory video, and this is going to be generally what GetVPN is, how it's basically set up, what's the single point of failure that you have to worry about, and some of the components that is involved with GetVPN. So let's get to the whiteboard/blackboard and start talking about it. All right. So let's start with the titles here because you know I got to put the titles up here. So we're going to go GetVPN. So for anybody that's studying for CCIE security, you need to pay attention to this because this is actually in the written, I believe, and you may see this in the lab. So what GetVPN stands for is Group Encryption Transport VPN. Now, what this is supposed to help you with is encrypting your clear text MPLS traffic. So what people generally think about with MPLS, let's just put a MPLS network in here real quick. Let's just say this is the MPLS network, and then we'll have some PEs coming off of this. Now remember, MPLS is just a transport technique or a transport technology, which means PE to PE, right? And it's really PE to PE based on labeling. I have a bunch of videos about MPLS if you want to watch them. There is a playlist, I believe, in general networking. It goes through MPLS. So basically, let's put some CEs in here as well while we're at it. Now, if you don't know what a PE to CE is, PE is provider edge, CE is customer edge. Now, depending on if you own your customer edge equipment, it may be you controlling this. If it's the service provider, it's the service provider owns the PE and the CE. PE means provider edge, CE means customer edge. So traffic that goes from CE, CE to CE is unencrypted. It's all in clear text. Meaning, if someone were to Wireshark right here, they could see the actual packet, the actual data that's being sent out. Now, you're probably going to say, what's the likelihood of that happening? Well, people used to do this technique or this thing called dumpster diving back in the day. And I'm dating myself. People used to throw out their Scantron paper documents and don't shred them. And people like me and fellow curious people they had this term called dumpster diving. You can get a lot of information based on what people throw out. So this is why you need to shred your documents because people still do that nowadays. I mean, it still happens. So you need to shred your documents and use a special type of shredder that just doesn't do linear, but it does vertical and horizontal, maybe diagonal as well, to really mince up your paper so it'll take somebody a very long time, and the work the work effort for that, they're probably not going to do that. So that was a side quest, by the way. But people still can Wireshark anywhere between the PEs and CEs if that should happen. And it really depends on how much they really want to see this data. And boom, they can see what all the data that goes through. It's all in clear text. MPLS is traffic separation. And that's where people think it's secure because, oh, I'm separating the traffic based on VRFs and all that good stuff, but it's still clear text going through that VRF table. So I want to definitely stress that. So what GetVPN does is there's a couple components here. So now you're going to add in these things called key servers. So let's say switch down here, and I'm going to do a simple design. It's a switch down here, and then you have a key server. Now, what the key server does is it centralizes this VPN technique, and it's called GDOI. When you configure it on the Cisco router, it's GDOI, but the whole framework or the whole technique is called GetVPN. So what happens is there's this thing, the key server is now responsible for this thing called, there's a TEC, which is traffic encryption key. There's a KEK, which is key encryption key. There's the interesting traffic, and then it's the public key of the key server. Okay, so those four things are components in GetVPN. So what happens is you'll configure the interesting traffic, you'll configure the traffic encryption key. You will also have, obviously there's going to be a public key that's going to get generated here from the key server, right? And then this KEK, there's a thing called rekey messages. So these rekey messages basically say, hey, when you want to regenerate the key, I'm going to send out a rekey message. So this is called a rekey message. And the rekey message will go out to each of these CEs, and they're going to be signed with, so say this is the rekey message here. They're going to be signed with the key server's private key. And if you didn't know anything about PKI, when you're signing something with the private key, you need the public key to actually verify that this is the original owner that sent it, right? So this is like the digital signature. So now the CEs will take the key server's public key that it got from the key server, the public key, I'm say pub key, and validate that that message is coming from the correct key server. And then obviously the rekey. Now you can manipulate when you want to send these key messages. It can be 5 minutes, it can be 10 minutes, whatever. You can do that. But basically what will happen is for the interesting traffic, you will have an access list on the key server that will say, let's say these were internal, right? Or yeah, let's say these are the interfaces are all RFC 1918s for the sake of this demonstration. So you would say 192.168.0.0 going to 0.0.0.255, and then that's the source, and then the destination will be 192.168.0.0, same thing, 0.0.0.255. Why would you do that? Because behind each CE, let's say this network was 192.168.1.0/24. I'm just going to use these numbers here. This was 192.168.2.0/24, and this was 192.168.3.24, for simplicity's sake. So what you're saying is, if any of these subnets behind the CE are trying to get to the other subnet, you're going to encrypt that traffic. That's basically what the interesting traffic is. And then everything here will be, when someone tries to wire shark on the edge or something like that, if they should happen to get to that, they will see ESP packets, right? They're not going to see AH packets because AH is not encryption at all, it's just authentication. This is going to be IPsec with ESP as as your transform set, basically. Or your phase 2 is going to be ESP. Phase 1 is going to be ESP. Well, phase 1, phase 2 is going to happen, but you're going to be encapsulating the packets in the ESP packet, and you will see that when you try to Wireshark any of these endpoints. Any of these here will be ESP for that interesting traffic. All right. Now, obviously, if you had something that was like if you had internet in your MPLS, when this was going to something outside to the internet, it would not match this interesting traffic value here, and it wouldn't be ESP, right? It wouldn't be encrypted traffic. It'd just be plain text going out to the internet. But as long as it's going from site to site, it's going to be encrypted. So now you have traffic separation. And encryption. Now you may need to do this for some type of regulatory some type of regulatory thing that you're trying to make sure that, hey, traffic is encrypted in rest in motion. So data at rest is going to be encrypted if you're doing that, and then data in motion is going to be encrypted. Now, data in use is a whole other topic, but data at rest should be encrypted, and data in motion, which is going from site to site, should be encrypted, right? You may have to have some regulation that tells you have to do that. Well, if you're using MPLS and you don't do that, well, then you're not complying to that regulation, right? Could you do this? And again, your ISP could technically, or your service provider could technically set this up for you. Do you see this out in the wild? That's probably the next question that I'm going to get. Yes, you do. In fact, I've seen GetVPN probably 10 times since, its inception. I've probably seen it about 10 times, right? Most people don't do it, and they don't realize that their MPLS traffic is clear text. But when they realize that, then they implement it, especially if you're stuff like banks. If you're a bank and you're having an MPLS backend, you should have GetVPN, right? Because you don't know anything anything that could potentially get leaked could be leaked through MPLS if it's clear text. So you want to make sure everything is protected. Now, what is the single point of failure? The single point of failure is the key server here. This key server is 100% single point of failure. So what you can do is do redundancy here. So you can have a key server here and have redundancy between the two. So if key server 1 goes down, key server 2 will take over and make sure that the key values get rekeyed, make sure if any new CE pops up that that's going to be a part of the encryption domain and all of that. So this is Don from Pilot Technologies. I hope this video was informative. This is a overview of GetVPN. You learned what it is, why it's important, some of the key components. The next video I'll put out, I'm going to show you a lab of GetVPN. I'm probably only going to have one key server, or if I have time, I'll just build 2 for redundancy, and then I'll show you MPLS clear text. And then when we apply the GDOI configurations on the CEs and the key servers, once we apply all that, then we'll do a Wireshark and you'll see that it's all ESP traffic or ESP packets for the interesting traffic. Hope this video was informative. Thank you and have a nice day.